Hey, what's up, guys? It's Sakani again, and here I'm about to help you guys out with understanding free store or heap. They both are interlinkable, but basically, free store is a pool of memory locations reserved for dynamic allocation of data. And I've written it on the board for you, so you can just write that down and I'll let you read all that. You can pause the video, of course. But yeah, free store is a pool of memory locations, sorry, reserved for dynamic allocation of data. Now, I've also written an example on the board. I'm going to go into that in a few seconds. So, to better understand what is the heap, you need to know what dynamic memory allocation is. And one of my colleagues has gone over that video, so you probably understand where it is now, or you've read it in the book. If you don't, reference those two videos, and then you can rewatch this as well, so you can have a better understanding. But I can basically say that it applies to the free store and the memory area where the operator knew, which is basically a language construct that dynamically allocates memory on the heap and initializes the memory using a constructor, which is another term that you'll find out as well from my colleagues. But it gets blocks of memory for allocation. Now, for this example, I've written int star p-value. We're going to write this out in programming languages, of course. You equal it into a new int. Basically, p-value is assigned 4 bytes from the heap already. So it's already assigned 4 bytes from the start. Now, when you make it to a p-array equals a new int, you multiply by 10 to increase the array, of course. And the point array will say it is, instead of p-array, is assigned 40 bytes from the heap. So basically, the exact locations of the memory allocated is not known in advance. The memory allocated has to be accessed indirectly. And if you're probably remembering something now, earlier from about a function, it just might click now. This is now why new returns a pointer. Remember what that does. Now, you don't have to put excessive emphasis about the mechanics behind the process of how free memory is located and allocated to the user. But it's worth knowing that sequential memory requests may not result in sequential memory addresses being allocated. Another example you could use, I kind of press for time a little bit, and I'll say that if you could imagine it, if you could write it out, int star p-value, like I have here, you equal new int, but you'll make that p-value 1. Now, then you'll make another one called int p-value 2, and that's another equal new int. This is an example of what I've said of how p-value 1 and p-value 2 may not need sequential addresses. So when they're dynamically allocated, variable is deleted, the memory is returned to the heap and can be reassigned as future allocation requests are received. Now, there are many disadvantages and advantages of this, of course. Allocated memory stays located until it's specifically allocated. So be careful of memory leaks, because memory leaks are the pointers that are destroyed, and there are no references to the dynamically allocated memory. Another disadvantage and advantage I could probably say is dynamically allocated memory must be accessed through a pointer, since they are undefined, so they're flexible to use in any shape, form, or fashion. They're stretchy like rubber band man. You can use that as a reference. But because the heap is a big pool of memory, large arrays, structures, or classes should be allocated there as well. That's another advantage. So basically, I hope this video helped you out to a certain extent. If you need better help and references, you can reference your book, and you can use this video and look for other videos that tie into this that might help you out. So hope I helped you guys out and broke it down for you. So study hard for those tests and study the vocab words.